I am Morris Maslia, representing the Environmental and Water Resources Institute of the Water Distribution Systems Analysis History Project. The purpose of this project is to document the history of water distribution systems analysis. An important part of this project is a series of interviews with engineers, modelers, researchers, and practitioners who have made significant contributions to the field of water distribution systems analysis. Our interview today is with Dr. Avi Ostfeld. Avi is a professor at the Department of Civil and Environmental Engineering at the Technion, Israel Institute of Technology in Haifa, Israel, and Vice Dean of the Technion's Erwin and Joan Jacobs Graduate School. Avi has over 25 years of research experience in water resources systems analysis, water infrastructure systems modeling, optimization, and water distribution system security enhancement through modeling. Avi is being interviewed today, May 19th, 2015, at the 17th Water Distribution Systems Analysis Symposium, which is part of the EWRI Congress in Austin, Texas. Avi, you are very active in the WDSA Symposium series, taking part in promoting several of the Battle of the Network Model sessions, as well as the editor-in-chief of the Journal of Water Resources Planning and Management. Can you tell us how you came to be involved in water resources, and at what stage in your career did you decide this was the direction you wanted to pursue professionally?
Thank you, Morris. The first time I heard about water resources systems was during my last year of studies at the Technion. I was an undergraduate student in ag engineering. I worked at that time as a student at the office of David Carmeli. David Carmeli is that same David Carmeli that was the leading author on the linear programming famous optimization model for branch water distribution systems. David Carmeli had a partner named Gidon Perry, which is not so much known, with whom I closely worked at that time on irrigation-related optimization projects, and especially on surface irrigation, some of which were in India. I think that positive experience brought me into the area of water resources systems analysis. In parallel, at that time, I was hired by Professor Gidon Sinai as a research assistant who was one of the pioneers on multi-quality analysis of water distribution system. This was during 1985, 1986.
You have studied under some of the pioneers of water resources, such as Uri Shamir at the Technion. Describe what role these people played and what impact they had on your career.
Okay, this is related to the previous question. When I was an undergraduate student at the Technion in 1986, excuse me, there was a legend going around at that time on an extremely interesting and difficult course and a brilliant teacher. The course name was Water Resources Systems Engineering 1, and the name of the teacher was Uri Shamir. Now, I haven't taken that course as an undergraduate student, but I knew that first thing that I'm going to do once I will initiate my studies is to go and talk to Uri Shamir and possibly be a student of him. I must admit that I was quite scared in approaching him. He was vice president for research at the Technion at that time, and he was Uri Shamir. Even then, he was Uri Shamir, or still then he was still then Uri Shamir. So it was quite frightening approaching him. So I recall the first meeting with him, which was in October 1987. I came to his office and introduced myself. He didn't know who I am because I was a student of him. He didn't took his undergraduate course. And then I remember that he started talking. Now, I remember searching for hidden tape in the room because he was so to the point definition on water resources systems and simply outstanding. And I've never heard anyone talking in that level of accuracy. So the meeting was about an hour, but when I got out of the room, I knew that this is what I want to do, and the rest is probably history. Uri was my advisor in my master's and PhD studies, and he's basically involved in all of my career. And I'm confident that without Uri I wouldn't be here, and basically I wouldn't be what I am.
You grew up and currently live in Israel, which is in the Middle East, where water supply and water resources are scarce and historically obtained from groundwater and water supply wells. How and what factors influenced you to work on water distribution systems analysis and not on the management of groundwater, which is a central water resource in the area?
Well, I could have likely been engaged with groundwater management. My interest in water distribution system is probably attributed, as with other things in life, to my first very positive exposure to this area. As mentioned previously, the work at David Carmeli's office, or even before that, I had a very good experience with Dr. Danny Cohen, who was my teaching assistant in irrigation engineering in my undergraduate studies, and I was involved later on with Kevin Lanzi in my postdoc in Tucson in 1997 in a study on surface groundwater interactions applied to the Hula Valley flood control problem in northern Israel, but my main interest remained with water distribution system, and this is basically where I feel comfortable.
Your professional and academic career has generally focused on 4 areas of water distribution systems analysis: water quality, reliability, evolutionary optimization, and water security. Can you describe and summarize where these focus areas began, what the current state of research is, and where research needs to focus in the future?
Okay, that's a big question. I will start with water quality. This is taking me back to 1986, I think, when I served as a research assistant at Professor Gidon Sinai's group. The work at Professor Gidon Sinai's group concentrated on multi-quality water distribution system management for agricultural purposes, though it was not concerned directly to water distribution systems, water quality analysis, as in today's you might say the EPA net generation. This was, by the way, the time in which the first studies of Walter Grayman, Dick Males, and others started to appear in the research literature, and right afterwards, I think in the beginning of the 1990s, EPA net. Okay, so next is reliability. I haven't done much on reliability, to be honest. I was engaged in reliability topics in my PhD entitled Optimal Design of Reliable Multi-Quality Water Supply System, which was an integration of design, reliability, and water quality consideration. I had afterwards 2 more papers on this subject, but not much more. In terms of evolutionary optimization, like almost everyone in this community, at the beginning of this century, I wanted to do something with genetic algorithms. So I then used other methods of this type, such as cross-entropy and ant colony, for single and multi-objective problems, for least cost design operation, and water quality. Water security. Water security is the main focus of my work. It started with Kessler and Sinai in 1998. That was probably the first model that was using unsteady conditions in placing sensors, not to mention the study of Rolf Deininger in 1991. Then the events of 2001, which really brought up front the problem of water quality in distribution systems and contamination in water distribution system. And then the work with Elad Zalomos in 2004 on inclusion of unsteady flow conditions in sensors placement modeling. And then several others on contamination source identification, response modeling, event detection, disinfection, and others. People that I can mention here are Ami Price and then Lina Perlman, 2 former PhD students of mine.
Avi, with your research group at the Technion, you are now investigating mobile sensors for contaminant intrusion events and security issues. What is your assessment of the current state of these technologies and analysis methods? What additional efforts do you see in the future for these areas of research? And when do you see these methods being used by practitioners in the water supply industry?
Okay, playing with the idea of mobile sensors is an interesting thing. There is a story behind this as well. I came across this idea of modeling mobile sensors for decision making after occasionally chatting with Emily Zekman, now Emily Berglund Zekman. I was giving a talk at one of the WRI conferences a few years ago, and that was a general talk on a review of the research literature on water distribution systems. And after the talk, Emily approached me and asked me why I didn't mention mobile sensors. I was surprised, though, asking her what are mobile sensors. I have never heard about them. And Emily then referred me to a project at Purdue and Texas A&M on mobile sensors, instrumentations, and I took it from there. So mobile sensors is a new technology which is really in its early stages of development. And there are a lot of issues currently associated with mobile sensors technologies, though I think it will take some time until it will become commercial. At the moment, what we do is we are developing modeling capabilities of using mobile sensors in conjunction with fixed sensor, though it's still theoretical. We try to capture reality with whatever we model. For example, battery life duration, data transmission uncertainty, operation constraints, and others.
Through your efforts as editor-in-chief of the ASCE Journal of Water Resources Planning and Management, the journal has risen to the #1 ranked ASCE journal. 3 follow-up questions. What do you attribute the success of the journal to during this time? 2, where do you see the journal heading or its focus being turned to during the next 5 to 10 years? And 3, what changes do you see for the journal in the coming short-term and long-term time frame?
Okay, as you know, I decided to step down on July 1, 2015 after 5 years of service. I think that the success of the journal is basically twofold. A very committed editorial board and a very helpful and professional ASCE team. Mentioning Kelly Anderson, Angela Conker, and Jennifer Chapman, and others. It really gave me the feeling all the way that we are all one team that is trying very hard to accomplish a mutual goal. In terms of forecasting, it's difficult to tell, to be honest. The journal is now in a very healthy situation with a good rotation of associate editors, an increase of submissions, and a reduction in acceptance rate. Things are now working nicely. I don't think that at the moment any substantial modifications need to be made. The journal scope, for example, submissions criteria, and others, we just need to keep doing what we do best and not be tempted to drastically move to different directions. I very much hope that the journal will keep growing and be good as it is now.
You have mentored many master's level and PhD level students as an academic advisor at the Technion. Explain your thoughts on or approaches about mentoring students. Do they come to you with an interest in a general area, or do you guide them into a general and or specific area of study and research?
Well, students for me are almost like children. I try to give them as much as I can. So this is a full 24/7 commitment, and I very much try to give them that feeling. I'm not accepting everyone. I very much rely on my intuition on whether our mutual journey, because that's a mutual journey, will turn out to be successful. Mentoring students is a big responsibility. Seeing a student growing up, succeeding, and becoming independent is a huge satisfaction. Just to mention a few, Ami Price in Vicente in Singapore, Lina Perlman, which is currently at MIT, Mashur Khush, that is here at the conference, that's a mutual advisory with Uri Shamir at the University of Haifa, and others.
Finally, a general forecasting question. Where do you see the profession heading, or what areas should the profession undertake in the next 10, 15, or 25 years?
Okay, this is a tough question. A way to try and respond to this is to go back in time and see where the field was and where we are now. There are different benchmarks, but one such benchmark point in time was the Water Quality and Distribution System Conference held in Cincinnati in February 1991. I attended that one, so I can refer to 3 examples and examine their evolution in time. The first one is water quality mixing at nodes. In 1991, We talked about full mixing assumptions and simplifications on this. Today you have computational fluid dynamics for receiving an accurate full picture. The second example that I can give is sensors placement. In 1991, we had the Deininger model, which I mentioned before, for steady-state sensors locations. Today we have multi-objective analysis, graph theory, evolutionary computation, mentioning TIVA spot, for example, and others. The third example that I can give for 1991 is optimal scheduling, a study that was presented by Brian Kuhlbeck, which was using, not just him, others as well, using traditional analytical methods like linear programming, dynamic programming, and others. Today we use data-driven models like artificial neural networks, model trees, and others. Excuse me, combined with evolutionary computation. An example of this is Zheng Wu from a Bentley system doing this type of things. Now, if you compare to 1991, which is almost 25 years away, I can say the following. One is that the basic problems have not changed. Those are the same problems. For example, our willingness to understand water quality, changes in water distribution systems, optimizing operation with water quality constraints, and other examples. So what has changed besides time? So the answer to this is technology. Not just the physical instrumentations of sensors, for example, or computational ability, but also algorithms and methods. For example, the use and development of evolutionary computational techniques such as genetic algorithms, which came into play in 1994. That was the first time that August Simpson has introduced to this community genetic algorithms, even though they were there before that. So what's next? I mean, if you're looking in 1991 and try to learn what happened from that time to now, what can you say on what's going to happen next? So in terms of technology and modeling, we have gone a long way on better understanding and solving through simulation and optimization water distribution systems related problems of a much higher complexity by all means. So much more complex systems are being solved with a lot of more complexity in terms of water quantity and water quality problems. Did it penetrate, for example, into practice? Not as much as I expected, as we expected, to say the least. And I think that the reason for that is, and in my opinion will always be, is the human interface. Because to what extent people outside of the, at least I will speak on my behalf, of the modeling, research, academic community are willing or prepared to adopt modifications. So to what extent people outside of our community are really prepared or ready to adopt this type of changes. The answer to this is not much. The field of water engineering is extremely conservative. I'm not aware enough of other fields, but definitely the water engineering field is extremely conservative. And we can, for example, look at a different example, which is, I think, is much more, which can give a much nicer example on this, on what I'm trying to say, and that is, to what extent has least cost design of water distribution systems implemented in master planning? So the technology is available somewhere. Studies started at the beginning of the 1960s, and they're available for over 35 years. And the answer to this is not really. I mean, even though people know, or the technology is there for least cost design of water distribution systems, not much has been done on incorporating this into master planning. If you go to offices that are doing water engineering, probably they won't use it. To summarize, I think that we will see much more technology capabilities coming in, which are related to data gathering and transmission and algorithmic and modeling adaptation to those modifications, sensors, internet, data, all these type of things. However, I think that the human interface will always be there as the major key player for leveraging the methods to the next stage of implementation, or the connection between technology and modeling. Between technology and modeling, you always have in between the human interface, and this will always be there. And if perhaps things will change, but if you look back to 1991, this is always the main constraint on trying to implement and trying to move forward on implementing new technologies into our field.
Thank you very much for providing us with your thoughts on some of the issues, questions that we deal with and face at WDSA.
Thank you. My pleasure, Morris.